Welcome to Made Simple with us, and I'm Kalawa. Today, we are moving on to the multiplication of two binomial in algebraic expression. So what then is binomial? When we talk about binomial, we say what is an expression of two terms. That is, let's say we have a plus 2 in one bracket, and then we have 3y minus 2 in another bracket. So these two brackets that have different terms are known as what? Binomial. We use the distributive property to multiply two given binomial. So that is, we multiply each term in one bracket, by each term in the other brackets. And I hope we are understanding it. So what we do, you see what? We apply this method for us to remove the bracket. So why do we multiply each term in one bracket by each term in another bracket? We do that because what? We want to remove the bracket. And after we remove the bracket, what do? We always what? Collect like that. So let me demonstrate to you on how it is actually work. For example, now, let's say we have a plus b. This is one binomial, and then we also have c plus d, and this is another binomial. So the statement previously is saying that we must multiply each term in one bracket by each term in the what? Other brackets. That is, they are saying each term in this first set of brackets, that is a plus b, we should multiply them by each term in the what? Other bracket. At this other term, they are talking about c plus d. So they are saying that this a, we are going to multiply a by c, and then this same a, we are multiplying it by what? D. And it also goes again to this second term, that is b. We also multiply b by c, and then this same b, we multiply it also by d. So how do we set this one? Now, we now set it this way. Let's take the first term out. This is what? A plus b, right? And then we also have another term that is what? C plus d. So if we take this first term out, this a, if we take it out, we are going to multiply this a into this other binomial. So this is how it's going to be like. And I want you to listen properly. So we say now what? A into c plus d. So what is remain? It remains what? The plus b. This same plus b, we are going to multiply it again to the other binomial. That is plus b into what again? C plus d. So this is what they are saying. Remember, we are now making use of what? This the first set of the binomial, that is what? The a and the b. So we have to multiply the first term into the other binomial, which is c plus d. And again, we are not yet finished with the first term. What is remain? It remains now plus b. The same plus b again, we multiply it again to the same other binomial that's remain, which is c plus d. I don't know if you are getting it, but I think I'm really trying to make it simple for you to understand. So if we go now, say what? A multiplied by c And then the same A, we multiply it by what? D. This again goes for plus B. B multiplied by C, and the same B will multiply it by what? D. So this goes A times C, this is what? AC plus A times D, this is what? AD plus B times C, this is what? BC plus B times D, this is what? BD. So let's see. Do we have any like term here? Of course, no. We don't have any like term here. But the method is saying that after we are removing the bracket, we now connect like term if there's any. But in this case, there is no like term. So let's take proper example and see how it works. So example, let's say we have A plus 2, and then we have A plus 3. So how are we going to do it? Remember, in multiplying two binomial in a given algebraic expression, it doesn't always mean that it's a constant law that we only use this, let's say, this first, let me use another color, this first binomial. Now, we can also use this A plus 3 to remove the bracket, either of the two. It works in both sides. So for now, we are going to use this first set. So we take them out, right? So remember, we are to deal with this first set, which is A. So we take the A out, and then we multiply into the second set of the binomial, which is A plus 3. A plus 3. So what then is remain? We now left with what? Plus 2A, plus 2, not A plus 2. So the same plus 2 again, we are going to multiply it again to the same binomial we did for the first one. So this is what? Plus 2, and then we take again into A plus 3. So do you see how it works? So after we set it this way, now we do the multiplication now. So A times A is going to give us A square. And then this same A, we multiply it to 3, is going to give us plus what? 3A. So what then is left to it? We now move to the second term. We say what? Plus 2 times A is going to give us plus 2A. And then this same plus 2, we multiply it to 3. Remember, you take note of the signs. That one I've dealt with in the previous video. You can go back and watch them. So plus 2 times 3 is going to give us what? 6. So now ask ourselves, do we need to collect like term here? I guess yes, there is like term. So we collect like term. Like term. So if we collect like term, you can see that we have here A square plus these two are like term. Let me give it another color so you understand. 3A plus 2A, they are like term. So this is what we refer to like term. And then what is left with plus 6. So we don't collect in like term. What do we do now? We add the like term if we are to add or to multiply or to divide. And then, but in this case, we have to add. So we add the like term. So this remains what? A squared plus 3A plus 2A. Remember, we have dealt with that. This is the coefficient of this A is 3 and the coefficient of this is 2. So we add the two coefficients and take one of the variable, that is one of the letter. So 3A plus 2A, that is 3 plus 2, this gives us 5. And we take one of the letters, which is A, plus b. So this is the simplest form. These ones, they are not like time. Let me put it to understanding. This a square, and just a, they are not like term. In this case, we have a positive sign here. And the law is saying that we have to only collect terms that have the same, but that are raised with the same power. In this case, this is 1 and this is 2. So they are not like term, and besides, there's positive sign between them, so they can never be like term. If it was a negative, a multiplication sign, then we should have using the indices power to simplify it. But in this case, this is the most simplified form. These two, they are not like term. They can never be like term. So don't see a square and then let's just take the fiber. Let's just say we say a square plus a. They are not like term because of this sign between them makes them not to be like term. You understand? But let's say we should have seen a square plus another a square. So these two are like term. These ones, they are like term because they are sharing the same power, and then they are sharing the same base, irrespective of the coefficient that might be in front of them. So these two are like term. So in this case, we should have what? 2, because we are dealing with positive signs. So we are not going to say, we are not going to add the power. No, because this is positive sign. So we are not going to add the power. We only add the coefficients. So remember, when a letter stands on its own, there's always one coefficient. So we add it. That's how we have 2 what? A square. So this is just a side understanding for you to get more understanding on what we are going through. Another example again. Let's say this is another example. But this one is somehow tricky, but it's very easy again. Let's say again we have 2x plus 3 all square, and then they ask you to simplify. And a lot of people will get confused in the first sight, but don't be. This is made simple with us, and we are going to make things very simple with you guys. So stay tuned. This again, remember, this is square. It means this whole term, or we can say this binomial, is being multiplied 2 times because it's raised to the power 2, which is square. So meaning this, we can separate them. So we can now say this 2x plus 3 into 2x plus 3. So 2x plus 3 square, this is the simplest form. It means we now have the same set, but it's being multiplied 2 times. So that's the meaning here. So 2x plus 3 into 2x plus 3 is the same as 2x plus 3 always to the power 2. Note that it's always the same. So let's go. So this again, we follow the procedure. We take this one and multiply it to this entire binomial, and then we take this same this 3 again and multiply it to this other binomial. So we now proceed. We say what? 2x, we multiply it into what? 2x again plus 3, and then what it remains now what? Plus 3. We also multiply it to 2x plus 3. So we move further. So what? 2x multiplied by 2x is very simple. 2 times 2, this is 4. And then x times x, this gives us what? X squared. We go again. So we done with this. The same 2x multiplied to the positive 3. So this means what? Plus 2x times 3. 2 times 3, this is what? 6x. Then we go again plus 3 times 2 again, this is what? 6x. And then this 3 again multiplied by positive 3. 3 times 3, this is what? 9. So what we do next is we collect like term. Remember, that's the rule. Whenever we remove the brackets, after which we now collect like term. If there's any, we collect like term. So if we collect like term, what are the like term here? And I guess this 4x squared plus, so this is like term. 6x plus 6x, they are like term, plus 9. So we proceed. This gives us what? 4x squared plus 6 plus 6. Remember, we have here positive sign. So we only add the two coefficient and take one of the variable. So 6 plus 6, this is what? 12x plus what? 9. So I think this is the most simplest form. We can leave it. So this is the most simplest form. So thank you.